The first law of power is that you need to make your boss look smart, not yourself. It's a very good lesson for any smart person embarking on their career to remember that you're not going to get a lot of points for making yourself look smarter than everyone else. You're actually going to get more points for making the other people look smart. Particularly, make your boss look smart is like the number one career advice.
What's up, everybody? Welcome to the Artists of Data Science podcast, the only self-development podcast for data scientists. You're going to learn from and be inspired by the people, ideas, and conversations that'll encourage creativity and innovation in yourself so that you can do the same for others. I also host open office hours. You can register to attend by going to bit.ly/ADSOH. I look forward to seeing you all there. Let's ride this beat out into another awesome episode, and don't forget to subscribe to the show and leave a 5-star review. Our guest today is a former Wall Street Quant turned data scientist who is leading the battle against churn using data as his weapon. He holds a PhD from the California Institute of Technology, aka Caltech, and has first author publications in leading machine learning and neuroscience journals. As a data scientist, he uses a variety of tools and techniques to analyze data around online systems, and his expertise has led to the creation of the Subscription Economy Index. Currently, he's a chief data scientist at Zuora, a comprehensive subscription management platform and newly public Silicon Valley unicorn with more than 1,000 customers worldwide. In his role there, he's been fortunate to analyze subscriber churn at over 50 companies in a large variety of industries. He's also an author and shares his experiences fighting churn in hopes that it can help other companies thrive in the subscription economy. So please help me in welcoming our guest today, the author of Fighting Churn with Data, Dr. Carl Gold. Dr. Gold, thank you so much for taking time out of your schedule to be here. I really appreciate you coming on to the show.
Thank you, Harpreet. Thank you for having me.
So talk to us about how you first got into data science and what drew you to this field.
That's complicated because I got interested in data science before it was data science. I was doing a master's in computer science, I'm going to date myself, back in the 90s. And I learned about AI and machine learning and, the state of the art back then. And I got really interested in that. So I went on to do a PhD at Caltech. And it was in an interdisciplinary program that combined neuroscience and machine learning. Now, that doesn't sound like so revolutionary now because everyone's trying to combine neuroscience and machine learning. But back in 2000, when I was doing it, it was a little bit more of a fringe pursuit for some academics. Machine learning hadn't really made a splash in the industry yet. So, that was how I got started. Although at the end of my academic years, for personal reasons, I left academia, and as you mentioned, I became a Wall Street Quant for a while. Back then, that was actually your main out from academia. If you were like a quantitative scientist or something back in the 2000s, and you didn't want to stay as do a postdoc, going to Wall Street was pretty much your best option. Nowadays, there is data science as a career, and so data science is probably the number one option for academics leaving, academia. And maybe I would guess that finance has been pushed to number 2, although it's actually a funny question. What's the number one choice for academics leaving academia now, data science or finance?
So what led to your interest in churn and what led to your creation? I guess, what is the Subscription Economy Index and what led to that creation and how does that fit together with churn?
All right. Okay. So 2 separate topics, actually. So the Subscription Economy Index is the analytics and statistical products that we make from the Zuora database. So Zuora's customers basically run their business on Zuora, meaning their customers subscription, and all their invoicing and billing and financing. So we completely anonymize that data, I should stress that. So we're not giving away any company secrets here, but so we completely anonymize and aggregate that data to answer questions about benchmarking. Well, the type of things we can calculate from that database are like the company's growth rate. How many new customers are getting? How much is their revenue growing? Also, because we have the customer database, we can calculate a churn rate for every company in our database. So we can provide benchmark numbers for what's a typical churn rate that we see. And then we can specialize it, for example, to different verticals. Like the average churn rate is usually higher for consumer companies than, B2B or business to business companies. So we look at things like that. And because Zuora also controls our customers' pricing and packaging, we do a lot of analysis around what's the best pricing and packaging for subscription products. So churn is just one of the things that we look at in the subscription economy index and the studies based off of it. I got interested in churn because a friend of mine asked me about it, really, when I was still a Wall Street Quant. I was thinking about getting out of finance at the time, and because it's a long story, but after the financial crash, the Wall Street world changed, and I wanted to get out of finance for a while, and I knew that data science had become a thing. I read the newspaper, so I was reading the news. Oh my God, machine learning is now widely used in some industry, especially in the Silicon Valley area where I'm living. So I was interested in getting into data science and making that lateral career move. Having done machine learning and had journal articles in machine learning, back before it was cool, it wasn't too hard for me. But I had to find the right opportunity, and I ended up working with a friend who was trying to make a product to do customer analysis, including churn. It was a small startup that was trying to make a customer analytics product for customer success and use cases like that. So he got me looking at churn problems because they were actually doing, it's a long story, but they were doing something else at the startup, and this was going to be a pivot. He had a junior data scientist at the time, and he was like, hey, Carl, could you look at this churn data with my junior data science? So I started helping them on that, and one thing led to another, and about less than a year later, I quit my Wall Street job and joined that company to try to make a customer dashboard for churn and customer success. And that was where I got into analyzing churn. And I did something like my first 15 or 20, I can't even remember now how many churn projects we did at that startup. I think between 20 and 25, actually, I did at that time. And that was honestly where I made some of my first mistakes. And I started learning how hard it is to, deliver a usable churn analysis.
So it's pretty interesting. You had quite the path into where you are right now, into full-fledged data scientist. You started off with the PhD studying machine learning with neuroscience. Now here you are applying it in the industry. I'm wondering, how much more hyped do you think the field has become since you first broke into it?
Oh, it's ridiculously hyped. Honestly, I'm someone who's in the anti-hype camp. I think, we're in the data science field, we're overpromising. Well, some elements of the field, I should say. And it's a lot, the media and journalism, they seize on one small result and they promise a revolution. Although a lot of people, other than myself, have pointed this out. And it's actually a lot of academics, even encourage this. It just helps their academic stature and their grant writing success to kind of hype up the accomplishments, and the media just eats it up. But then when you get to being like a practicing data scientist like us, we get unrealistic expectations from our customers. I mean, when I started out, of course, people thought machine learning was trash. This was like, when I went to Wall Street first, no one was that interested in machine learning, back in the early 2000s. It wasn't until after Google essentially, had showed how much they could do with machine learning in a production environment with big data. So it was only around 2009 or 10, I think, that machine learning really became respectable.
And where do you see the field headed? Where do you see the field, with data science and machine learning? Where do you see this headed in the next 2 to 5 years?
I think it's going in a great direction as it is. I mean, just because I think that we've kind of overpromised in some cases in machine learning, I don't mean that that's like a crisis in the field. I do hope that in the next few years that some expectations are already starting to come down, actually. Yeah, so I do hope that people get more realistic expectations coming up. And you can see this really, for example, in driverless cars. Like, do you remember back in 2015 when all these driverless car companies were like, oh, we're going to have driverless cars by 2020? Now, at the time, I wasn't working in driverless cars, but I knew machine learning and I knew AI. And I just told anyone who would listen that that was complete BS. And that we'll be lucky to have driverless cars by 2030, with the current understanding of intelligence and the brain. So the hype has definitely been sucked out of driverless cars. And there's probably a lot of other areas of machine learning that have been overhyped where we still have a little hype deflation is still needed in some areas. But at the same time, machine learning and data science are delivering great things. I mean, first of all, when you talk about data science, it's not just machine learning, it's also statistics and advanced analytics. And what I show, in the Churn book is that your advanced analytics can really do most of what most companies need. And machine learning is definitely appropriate for a lot of more advanced use cases.
So what do you think would be the biggest positive impact that data science will have on society in the next 2 to 5 years?
Wow, that's a deep question. I hope that data science is making us more productive. I mean, everyone says, well, we should be more data-driven. Well, what's the result of being more data-driven, right? Well, you should make companies and individuals should make better decisions faster. And I know it's making all these companies more productive. It's one of those confusing questions because the economists say we're not becoming more productive as a society. But I work in an industry, and you do too, where I feel like I can see increased productivity constantly. And I don't know why, why it doesn't come out in the economist numbers. Maybe it's because data scientists' salaries are so high, it kind of like eats the productivity or something.
Yeah, definitely. I think it's enabling us to automate away some tasks so that it frees up other people's creativity to perform other tasks, right? Which just compounds in itself.
And it should enable better decisions too, not just faster decisions. By getting the right data to the right people and giving them the right tools, we really should see companies making more optimal decisions.
Definitely, I agree with that 100%. So what do you think would be the scariest application of machine learning and data science in the next 2 to 5 years?
Probably the scariest applications now seem to have to do with the spreading of false information. I mean, we're not quite at the point where we have, Terminator robots hunting us down. That's one of those, overhyped fears. But definitely, deep fakes and making misinformation harder to root out in the social networking world is definitely very scary if you look at what all this disinformation is doing to society right now.
Yeah, I definitely agree with that. So as practitioners of data science and machine learning, what do you think would be some of our biggest concerns when we're out there doing our thing, doing our work?
Well, as a data scientist in the trenches, your main concern is usually not to, make mistakes. Don't project your biases into your work is always one concern. But there's also, of course, the ethics question, which is getting a lot more talk. I was just listening to a webinar where someone is saying there should be like a Hippocratic oath for data scientists, which means that goes beyond just you don't want to make mistakes. It means that you shouldn't be working on those, on those dangerous applications. Like if someone asks you, hey, can you help me make a better deep fake bot to spread false news on Twitter? You should say no, But the truth is there's a lot of people out there, who will even see those types of applications as a legitimate weapon in their cause, even if it's harmful to the world at large. Did that really answer the question? I'm not sure.
Yeah, no, that was really interesting. Like a Hippocratic oath for data scientists, I think that makes 100% sense. Like that absolutely should be something that we should be thinking about, because as we are moving into this future where applications for data science can essentially they're ubiquitous, right? They're everywhere. And injecting your biases into things and coming up with these weird deep fakes to like mislead people, that's dangerous stuff. Yeah, I think a Hippocratic oath for data scientists, I think that is a freaking awesome idea. What's up, artists? I would love to hear from you. Feel free to send me an email to theartistsofdatascience@gmail.com. Let me know what you love about the show. Let me know what you don't love about the show. And let me know what you would like to see in the future. I absolutely would love to hear from you. I've also got open office hours that I will be hosting, and you can register by going to bit.ly/ADSOH. I look forward to hearing from you all, and I look forward to seeing you in the office hours. Let's get back to the episode. So I want to get into your book here, your book on churn, which I thought is amazing. It is chock full of so many examples and coding examples, and I've never seen churn treated so thoroughly. So I was really excited to go through that book and then get you on the show for this. So let's just start at the top. Very basic question. What is churn? Is that what we do when we make butter? And
No. For everyone who doesn't know, churn means customers quitting or canceling. And the term comes from the churn rate, which is a metric. And they call it the churn rate because it's the turnover in your customer base. If, say 5% of your customers cancel, then you have to replace those 5% with new customers before you can keep growing. So it takes out of your growth. They call it churn because churn refers to turnover or mixing. But now if you're in the business, the SaaS or software as a service industry, people use churn as both a noun and a verb. Like we will call a customer a churn. We'll say, oh, that account, they're a churn. Don't worry about them. Or make a report on last quarter's churns, which is clearly using churn as a noun. And then you can also use it as a verb and say, oh, the customer is churning or the customer churned in the past tense. And some of us who really spend a lot of time on churn will even talk about our own churns and say something like, oh yeah, I'm going to churn from Hulu because, I finished the last season, I don't know, Survivor, whatever you're watching on Hulu. So why is noun and a verb.
So why is churn so hard to fight?
I think it's hard to fight really because it depends on actually giving more value to your customers. And there's no quick fixes for churn, or rather there shouldn't be. In a mature product without serious bugs, there's no quick fixes for churn. And it's also hard to fight because the solutions need to be customized to the causes, that there's many different causes for churn typically. Typically it could be either the customer's not using the product, or maybe they're using it incorrectly, or maybe they signed up for the Premier plan, but they're not taking advantage of all the features. And you need to know which of those reasons is the reason for churn to do something about it, which is actually why in the book I explain it's not always a great use case for machine learning, which just gives you a yes or no prediction. Most companies, if you give them yes-no churn predictions, it's not actually very helpful to them because what they need to do is they need to segment the customers based on the cause of the churn and then take some kind of targeted activity. Like if you find a segment of customers that are not using your product's best feature, for example, then you want to reach out to those customers and say, hey, do you know that about this great feature you're not using? But you don't want to send that same email to the customers who are already using the feature. So in churn, there's no one-size-fits-all solution, which means a simple machine learning approach of just predicting it doesn't really help. And that's another thing that makes it really hard to fight churn.
So is that what also makes it hard to predict when a customer is about to churn because there's no one-size-fits-all solution, or what is it about churn?
Sometimes you can predict churn pretty accurately. Although it is often hard to predict churn, there's a few reasons that make the accuracy of churn prediction difficult. One is that you never have all the information that you'd like. I'll just make a very simple example, like the amount a customer pays for a product is an important factor in churn, but it would be really helpful if you also knew their disposable income, for example. Or if then you'd know, how much is that cost to them. Another thing, like if it's a business product, well, you'd really like to know your customer's revenue, right? You'd like to know everything about their business, and that would help you know if they're a churn risk. Well, guess what? You're not going to get all that information ever. So you're always faced with incomplete information about churn. And there's also a lot of subjectivity in it too. So if you take a consumer product, and this is related to the incomplete information, you'll never really know if someone likes it or not inside their subjective, heart. You don't know what they're really thinking. So you're relying on all these other variables that you can measure to infer things about what you can't measure, which is the customer's true satisfaction. And then lastly, there's the timing effect, that it can be hard to predict the timing of churn, even when you know someone's a churn risk. Usually in a churn, if you do the analytics or machine learning for churn, it's very easy to see people who are highly at risk, because guess what? They're the people not using the product at all, right? But then when you take those people who aren't using the product at all, it's still really hard to figure out when they're going to churn, because, well, we all have this experience, like, hey, I haven't watched anything on Netflix for 2 months. Oh, what a waste of money. I should cancel Netflix. And then you forget about it. And then a week later, you think about Netflix again, and you're like, oh yeah, I meant to cancel Netflix. And many of us go on like this for months. Actually, Netflix introduced a new feature where they're going to auto-cancel everyone who hasn't signed in for 2 years, right? Now, that's nice of them, but that just shows there are people who haven't signed into Netflix for 2 years and they haven't churned. So how's a churn prediction algorithm, or churn prediction system gonna deal with that? So you've got incomplete information, subjectivity, and the timing, has so many extraneous factors in it. So it's hard to get a very high accuracy on churn prediction.
That brings me to my next question, which was the importance of metrics in our battle against churn. So correct me if I'm wrong, but it seems like that everything you just kind of described is also the importance of metrics, or is there anything more about metrics that we need to know when it comes to our battle against churn?
Well, the point about metrics is, really common in data science, just that your features are super important. And the features that you choose, in my mind, are really the main part of solving any data science problem, and not the algorithm. I show actually in my book that if you do a good job on your feature engineering, the algorithm that you choose is not that important for your accuracy. So feature engineering always has, number one importance in data science. And in churn, you're typically working from raw data where you just have a bunch of events that occurred in data warehouse, and you have to design summary metrics of the customers. So it's very important how you choose those metrics for your ultimate accuracy, and also, even more importantly, for the understandability of the model. Because, like I was saying, to take action on churn, the people in the business, like the people who do the email campaigns or who call up customers, they need to understand why people are churning, and they need to understand what a healthy customer looks like. And so if you don't have interpretable metrics which actually predict churn, then, that's what you need. So the metrics have to be interpretable. And as I show in the book, you can make any metric predict churn if you design it correctly. That one metric won't be a perfect churn predictor, but every metric that you use should be a churn predictor that the business people can understand.
Yeah, I absolutely love that about your book, how you really went deep in on metrics and feature engineering. And I want to talk to you a bit about feature engineering a little bit later, but I loved how you had really thorough, well-designed coding examples that we could use to go from raw event data into metrics, and laid out in SQL code and Python code. And I thought that was a really amazing thing in your book that I haven't seen done in most other books, like at that level of detail. So while we're on this topic of metrics and designing metrics, like how do we go from raw event data to metrics? Do you have like an example for us so that we can kind of conceptualize what you mean by that?
Yeah, the most basic metrics are simply a backward-looking count or total of some kind of event. So your events might be things like, let's say it's a social networking app, and your events might be posts. So every time someone makes a post, it's an event. Now, a metric would be something like posts per month or posts in the last month for each customer. So it summarizes the raw data, and it makes it into a feature that can go into a machine learning algorithm.
So talk to us a bit about cohort analysis and how do cohorts help us analyze and predict and understand churn?
Yeah, well, this is, again, obviously you read the book. This is one of the main themes, which is that I introduced a technique that I called metric cohort analysis. Most people are familiar with cohort analysis, in which you observe a bunch of customers who sign up at a certain time and they form a cohort, and then you look at them over time, like 1 month, 3 months, 6 months later. And the idea is that you look at those cohorts and look at the churn in the cohort. So you're looking at the churn rate in the cohort at different points of time. For metric cohorts, I group the customers by the value of a metric. So if it's, say, posts per month, you would cohort customers based on the amount of posts they make. So you might have a cohort of 0 to 10 posts per month, and then the next cohort will be, 10 to 30 posts per month, etc. And you always have a long tail of outliers in these, and you'll have a few people who are making like thousands of posts per month, But the cohorts are, you can just think of them as the percentile grouping of those customers. And then the interesting part is when you look at the churn rate in cohorts formed based on behaviors. And that's where you'll see that typically people who use the product the most are going to churn the least. And then people who use the product the least churn the most. That's the method for empirically showing that your metric is predicting churn. And it's a great method because it's really easy to explain to business people. I mean, if you do, you can show the same thing with a regression, right? And you come back with a regression coefficient. But I find that when I go to business people and I tell them the regression coefficients and the p-statistics, they give me blank stares. But if you show them a plot that shows that, people who post from 0 to 10 times a month churn at a 20% rate. But if you have customers who post more than 50 times a month, then they only churn at a 5% rate. People really get that. People get it. Oh, wow, we want our customers to be posting at least 50 times a month so that they're in that, they achieve that healthy low churn state of the heavy product users. So it's really, for me, like a cornerstone of how I convey this information to the business users.
Yeah, you talk about the single most important concept in the book being the ratio metric. So I think you kind of touched on that, but just for sake of clarity, can you define what the ratio metric is, or what ratio metrics are, and why are they so powerful?
Okay, so I made the simple example of like a post per month metric. Now let's say there's another event in the social network, which is like the ads viewed by a customer. This is an example out of the simulation in the book. So now viewing ads is usually bad for customers, right? You expect that people who view more ads might be driven away from your service, like if they're seeing a lot of ads. But the funny thing that you find usually is that you don't actually see those negative correlations between behavior and renewal, or it's a positive, you don't see those correlations between a bad behavior or what should be a negative behavior and churn. And the reason is because there's both correlation and causation happening, which is that in any service, you have power users who use it a lot. And they have both a lot of good events and bad events. So for example, a power user is going to see a lot of ads and make a lot of posts. And they'll probably get a lot of likes and a lot of shares and, all those other things too. But the power user has a lot of ad views, which you expect to be negative. But you find if you look at a simple correlation between ad views and churn, you'll see that the more ads someone views, the less they churn. So you're like, wait, I thought ads were bad. How come people who view more ads churn less? Well, it's the correlation for the power users. So now this is a long way I've been coming roundabout. A ratio metric is just a ratio of two other metrics. So it looks at one behavior in relation to another in a way that's very interpretable for normal humans. So in this case, you might look at a metric like ad views per post. So you take the ad views metric and you just divide it by the post metric. And they were both, for example, measured on a monthly window. And the reason you do that is because it separates out what's going on. By making it a relative metric, the ratio, you'll actually see, does someone get a lot of ads relative to their amount of use? And the same trick, I actually didn't start doing this with ads and posts. I started doing this with money and behavior, because you see the same thing in products with multiple price points, where there's like a basic plan, a standard plan, and a premier plan. When the premier plan is the most expensive and the basic plan is the cheapest. So then what you find is that people who pay the most churn the least. Why? Because the people on your premier plan have self-selected. They're like a self-selected group of people who are really into your product. So that's why they're on the premier plan. So from this, you get the correlation that the more people pay, the less they churn. And you're like, okay, well, it actually makes sense when you think about power users. And it's the same thing with B2B products, business products, where bigger customers always churn less as well. So if you do enterprise sales, your bigger customers are usually your best customers. But again, you've got this correlation between paying more and churning less, which is actually, it's not that it's not true, but it's not the right point to make. The money case, you look at the ratio metric of dollars per use of the product. Like, let's say your product allows you to share videos, right? And you have a metric for number of video downloads from your site per month. Then you would look at like dollars per video downloaded, and then you're actually seeing what kind of a value the customer gets. And so the ratio metrics actually allow you to, in an interpretable way, normalize the behavior relative to the size or the level of the customer. And there's lots of other ways to do this in data science. For example, if you do a dimension reduction with PCA, principal component analysis, you get factors made up of the normalized difference between different metrics. And normalized differences are actually another way to get this same information into your model. It's the relative difference between two other metrics. Now, the problem is in interpretability, and that's where ratio metrics really win, is if you go to your business users and say, I made a feature which is the difference between normalized revenue and normalized usage, you're going to get blank stares, right? But if you say, I made a metric which is dollars per use, people say, oh, that's great, a dollars per use metric, because for some reason, ratios are very intuitive for the human brain. Now, this is actually getting out of my area into like cognitive psychology. Like, why are ratio units very easy to understand? In a contrast, if you ever took a physics class, which probably most data scientists have, multiplicative units are impossible to understand. Like kilowatt hours or, gram meters or, any multiplication of two units is very difficult for humans to intuit. But we're very easily intuit ratio units. And I pretty much just latched onto that fact and centered my analyses around ratio metrics and ratio units because it's very easy for the business people to understand. Yeah, so that was a long answer. Sorry for that.
Great. No, that is absolutely great. I know that the audience is really going to enjoy that because that's super insightful. And you go in such amazing detail in your book. I highly recommend everybody listening to check it out, especially if you're working in e-commerce or working anywhere where churn is an issue. This book is really going to provide a lot of benefit for you. So I wanted to touch on some other things that are tangential to your book, but I think the audience will love to hear your perspective on this. First, talking about outliers. So you mentioned outliers a little bit previously, but why are outliers so problematic to deal with?
Well, they're only a problem if you don't deal with them. But I mean, they're really common just because of the long tail of behaviors. Like you've always got power users who just hammer your product, right? Your typical user might make, 10 posts a month, and then you've got people making thousands. And they're problematic in many types of analyses, although it really depends on what you're doing. They're not a problem for a lot of machine learning algorithms, depending on what algorithm you choose. They're definitely a problem for regressions and averages. And, they'll just blow away anything based on an average because the outliers will dominate. I'm sure, anyone familiar with data science has heard, the many different problems with outliers. Although the thing is, there's different types of outliers important to distinguish. There's false outliers, which, well, ideally you would just detect them and remove them because they're bad data. But the thing is, in the customer behaviors, you get this long tail of genuine outliers, and those you want to incorporate them in the model and get information from them, but without them, ruining, your numbers.
Yeah, that's going to be my next question was, what are some common mistakes that you've seen data scientists make when it comes to dealing with outliers? And I think that's probably one right there where it's like the outlier is actually kind of useful.
Yeah, you definitely want to use them. I mean, the first thing to do is, of course, just normalize your data. Although I should point out, not just a standard normalization. I use log-based normalization. So you take a log scale of the metric if you have a lot of outliers, it's very helpful for your analysis to take a log scale of the metric. And then you can apply a standard normalization procedure, like subtract the mean and divide by the standard deviation. But it's that step of taking the log of the metric. And you have to be careful with zeros too. So typically you do log of 1 plus the metric is what you do for that. And so then you don't have that problem with your data being, so spread out because you pull it all into a small scale. The other trick I like to use for outliers is actually trimming the outliers rather than removing them. And trimming the outliers, it's actually known as, I think, Windsorization. And this is one of those funny stories where in World War II, Lord Windsor came up with a statistical technique to analyze the bombing raids or something. I think that's the real story, if I got it right. And they called it Windsorization. And what it means is that you trim the outliers to a high level, like the 99th percentile, without fully, removing them. It's funny, you're making me realize something I didn't mention is the problem of outliers. I think a lot of statistics textbooks have it wrong for big data because they'll tell you can't have outliers or it's going to ruin your model. I actually don't find that really. If you have a decent amount of data, outliers don't usually affect your model too much, is what I've found. And by a decent amount of data, I mean, like 10,000 or more examples. Then if you have some extreme outliers, they honestly don't change like your regression coefficients too much. But what I see is often another problem is you get unreasonable predictions on an outlier. So you might get a reasonable model, like a regression, even including outliers. But then when you turn around and make a prediction for an outlier customer, you'll get really extreme values. Like, it's never true that anyone's like 100% likely to churn or 99% likely to churn or 0% likely to churn. But if you keep outliers in your prediction data, then you'll get these really extreme predictions. And business people just hate that. And you have to spend all this time like explaining to the business people, oh, it's not really 100%, it's just an outlier. But it really reduces confidence, in the model. So sometimes what I've done is I've ignored outliers when fitting a model. But then when I predict with the model, if I'm going to return scores or probabilities to the users, I make sure to screen the outliers, or rather trim the outliers in the prediction, because it just avoids stupid questions, with the business people. That 99% churn will turn into like a 70% churn after you trim the outlier. So you'll still consider it like a risk, but you just won't have to explain so much to the business people. So
yeah, I absolutely appreciate that explanation. Thank you for that. And I definitely understand the need for having to put things in the perspective of the business users, right? Sometimes you're going to have to do some things that maybe don't sit quite right with you as a data scientist, but hey, at the end of the day, you're communicating with business stakeholders and you've got to make this stuff approachable and accessible for them and easy for them to understand.
And just not leave things that will make them question it. If you do trim like an outlier churn probability from like 100% to 70%, right? 70% is really still a high churn probability.
Yeah.
So you're still telling the business this customer is at risk, but you're not giving them a number that will make them question your modeling,
Mm-hmm. So we touched a little bit on feature engineering just a little bit earlier. I want to dig a little bit deeper on that. I 100% agree with you that feature engineering is really the most important part of the entire process. But what are some tips that you could share with our audience so that we can be more thoughtful or more, acting with more ingenuity when it comes to our feature engineering?
Well, for customer churn, let me just focus on that. The first thing I tell people is to focus on features that are close to the value the customer receives. I mean, we kind of touched on the fact that the customer's value in their mind is subjective, and you're never actually going to know exactly how much they value the service. But if you have, for example, let's say it's some service where you create documents, right? And you have one feature for the logins to the system and one for creating documents. Like, well, which one's going to be more important, right? Probably the one for creating documents, because that's the feature that is closer to the value creation. And the login to the site, well, that's just a gateway they have to pass through. But generally, modern products are over-instrumented for customer data science. They instrument every little click and thing that the customer can do. Or maybe not everyone, because even, no product can be that completely instrumented. But you're generally collecting a lot more events than you actually want to use in an analysis. So the first thing is to just try to focus on events that are close to the customer value. The second most important tip is really about just dimension reduction. And in the book, I kind of advocate for a simple approach to dimension reduction, but the foundation of it is to look at the correlations and look at what behaviors are correlated with what. Because very often, again, in this over-instrumented product scenario, you'll have 20 to 50 metrics that are all highly correlated with each other, different parts of some process of behaviors. Like, again, the hypothetical document editing application, you're going to have edit document, save document, open document, and all those behaviors are going to be highly correlated because a customer who does a lot of one is going to be doing a lot of the others. So you've got to get to the bottom of those, pile-ups of correlated metrics by reducing the dimension. And also it gets back to ratio metrics, because if you do have a lot of correlated behaviors, there could be some interesting information in the relative difference of those between those behaviors. Now, you would naturally pick those up if you used a principal component analysis to do your dimension reduction. Then, of course, the problem with PCA is you can't explain it to everyone. Even myself, I honestly have a hard time understanding, PCA results. So the problem with that is that it's hard to explain. So that's where you get back into this area of ratio metrics. If you want to look at the relationship between behaviors, but keeping it interpretable for the end user. So the ratio metrics are actually another important trick with the feature engineering.
So you talk about the common misconception that the choice of algorithm is the most important thing that contributes to model performance. Where do you think that misconception stems from?
Well, it definitely stems from academic work where the data set is fixed as a benchmark data set. I mean, you read all these academic papers, a couple of academic papers that I've written on machine learning. You start with a benchmark data set, and typically your goal is to show that your new algorithm is either better or the same as the previous ones. And in these scenarios, feature engineering is actually not really an option, because with a benchmark data set, you don't have the raw data. So it's actually almost impossible to teach feature engineering because you need real raw data, to do it with. And then you actually go through the process of making the features. So I think it's just the confluence of how data science and machine learning are taught and reported in academic papers. Like, if you just read the literature, you would conclude that the most important thing was the algorithm, because that's what everyone's writing about. No one's writing paper about, feature engineering. And again, that's partly just because they don't have access to the raw data, which would even enable them to study the feature engineering. You have to be a practitioner out in the real world to actually have raw data to play with.
Yeah, the raw data plus a little bit of intuition about the industry that you're in, about the use case, and combine that together, come up with some really creative features that you could then use to build a product model.
But it doesn't have to be creative. I mean, basically in the book, I lay out a cookie cutter process, It's like, start with count metrics on everything, maybe some sums and averages if you have appropriate features. Then look at correlations, and then from your correlation analysis, think about what relationships might be interesting. So it definitely takes domain knowledge and some ingenuity. But I think once you study the process, I feel like it actually doesn't take too much like real creativity. I hate to say it. I mean, it is creative to a degree, but once you get, honestly, this is partly what inspired me to write the book, is just that we had come up with kind of like a cookie cutter factory process to come up with good metrics and, deploy churn models. So in a way, the feature engineering, you mentioned that I really focus on feature engineering in the book. And honestly, it was really my inspiration, was a lot to share the feature engineering techniques. So in a way, I would say I wrote a book about feature engineering, but it's in the use case for churn. So
yeah, that's what I really enjoyed about that book, is you give it a nice, thorough treatment. Like every topic in there, it's like literally a Bible for churn. If you're listening to this podcast and you're interested in solving churn problems, like this is the book to get 100%. So speaking about deploying models into production, I think that's something that doesn't get nearly enough coverage in any book, really, is what to do once it is in production. So once we fit a model and we ship it, does our work as data scientists stop there?
No, of course not. And I don't go too much into this in the book, although I point out the need, you should definitely set up your models with code and not with ad hoc, procedures, because it's inevitable that you need to rerun your model. It's a little bit complicated because, there are studies that show that churn prediction models become less accurate over time. And so that forces you to refit the model. And it makes sense because the world is changing and, the customers are changing, the competitive landscape is changing. And if you ever believe that there has been a big change in your competitive landscape and your customer behavior, you really must refit the model, because what it's not going to be telling you the right thing anymore. It's a little bit harder to know how often to change the model in general, because changing the model has its costs as well, because you have to go back to the business people and explain everything to them again, and they're going to get confused. And generally, it's a best practice not to change your model more than once a year, unless you have a strong reason to do so, just because the change is going to impact the users. There's even examples, there are companies I know where the customer success reps are they're monitored for how much they reduce churn risk, right? So the reps are actually being monitored and expected to impact the model output by getting the customer to do better behaviors. Now, the thing is, if your reps are being graded based on their performance in improving this model number, you can't change the model mid-year. It's like you're moving the goalposts, right? And that's a whole nother problem. So you definitely need to refit the model, but then again, the papers will tell you, oh, your model is losing accuracy after just 3 months. But you have business needs that you can't update your model after just 3 months, unless it's an emergency. Actually right now, due to COVID, I'm telling everyone to update their model, right? Right now, if you do a new churn model, you should really only use data since COVID, if possible. That'll only be possible for a consumer company that has a lot of observations. Generally, business-to-business companies have a small data challenge, because their customers are on annual subscriptions and they might not have that many thousands of customers, maybe even hundreds of customers, then you have a real challenge in collecting a new data set. And it would be impossible really for a business-to-business company with only a few hundred customers to create a new data set with only renewals since COVID, only data since COVID. They'd hardly have any data left. So there's so many competing concerns with refitting your model. You're absolutely right that the job doesn't stop once you've deployed. We haven't even really talked about the technical aspects of, deploying a model in production and monitoring its output. That is also something you need to do. You should continuously monitor your model's predictions for accuracy, because that'll actually give you the warning sign if it's been too long.
Yeah, thank you so much for that. Yeah, I was right about to ask you. The next question is, what are some things that we need to monitor and track? Let's say specifically the context of churn, to make sure that our model is doing what it should be, that it's performing as we've designed it to perform, from both, I guess, the data science type of perspective on the back end and from the business perspective.
Yeah. Well, Definitely in terms of accuracy, I advocate using back testing, or they also call it cross-validation through time. So to measure your historical accuracy, I actually advocate doing like a historical simulation of you fit the model as if it were a certain point in time, and then you only predict on customer churns in the future from that backdated time. And that's to prevent what they call look-ahead bias, which is using ahistorical information, in your model fitting. So that extends just to live modeling, where you should be checking the accuracy of your model periodically. Always, of course, is that, in a validation framework. So you test the model on data that you didn't use to fit the model, but you do that moving forward through time. And so that's going to be definitely one of your big things to make sure that the model is still performing as it was intended to.
So you spoke a little bit about how COVID is messing up churn models. So what is it about this situation that is going to be making it difficult to predict churn going forward? Is it because all of a sudden people are just unsubscribing from things just out of fear and panic, or what is causing this kind of...
It's all kinds of change, actually. I should stress that there's not like a churn crisis due to COVID. It's actually very specific because some companies are seeing a boom, like booming business, like Zoom Video. I'll mention them because they're a Zuora customer. We're very proud that our customer Zoom has gone to being a household name in the past 3 months. And I know from looking at their system data, I think they have something like 4x as many subscribers as they did in January right now. So their business has exploded. But then on the flip side, you have companies where their business had to do with, say, sporting events or travel. And those companies really are having a churn crisis due to COVID. But the thing is, in both cases, you have a big change that happened, which means that when you do your empirical analysis of churn and behavior, you're going to see, what behaviors are typically correlated with churn, or what level of use of the product is considered a healthy level. But when you have a changed business environment, you have to discover the new normal. Just hypothetically, I'm just completely making numbers up, but if you were some video service, not Zoom, this is not at all based on any real data from Zoom, but let's say you were a video conferencing service, and in 2019, you thought that a healthy usage number would be 5 conferences a month, and above 5 conferences would be considered a healthy customer. Well, guess what? It's 2020, and 5 video conferences a month is nothing. Now, a healthy customer not at risk for churn probably should have 20 video conferences a month because usage of video conferencing has gone up so much. So that's like a positive improvement in the business. Now people are doing more video conferencing. But if you now want to identify churns, you need to refit to the new normal of customer behavior. And that doesn't matter if your churn went up or down. You got a new normal, so you need to redo the empirical analysis. And if you're using a model, refit the model.
Thank you so much for that. And thank you for going into a deep dive on your book. There's so much in this book that I wanted to cover, but we would have run out of time. But yeah, there's 11 chapters, really clear examples, really well-constructed examples. I think anybody who is interested in churn or wants to learn more about churn should get their hands on this book. So shifting gears a little bit here, I've got some questions that I want to ask that are not about churn. First is, do you consider data science and machine learning to be an art or just purely a hard science, and why?
Well, that's funny because I have a PhD in hard science. It was in a biology division, but I was doing computational work. I consider hard science to be partly an art, just in the sense that it relies a lot on intuition and creativity. The difference between science and engineering, in my mind, is that if you're doing science, you're doing something that no one else has ever done before. You're doing new research. And it could be new research on your own company. If no one has analyzed churn at your company, then you're actually doing science because you're going to do an investigation that no one has done before. And I do think that pretty much all science is to some degree an art because, there's too many hypotheses to possibly test them all, right? So your first step in a scientific project is going to be to narrow down the hypotheses to the ones that make the most sense. And a lot of that, it's kind of an art. It uses some gut instinct. It uses your domain knowledge. It uses your knowledge of the modeling, what's possible. So I feel that a very important component of science is really an art. So I would say that extends to data science. Whenever you're doing a new problem that no one's done before, there's an element of hypothesis testing. And like I said, you can't test all the hypotheses. So you're going to have to use your creativity, your domain knowledge, your intuition, and your experience to come up with the best ones.
Yeah, I was watching a documentary recently about babies. My wife and I just had a baby about 3 months ago almost.
Congratulations.
Thank you. And just these experiments that these scientists were coming up with to test these various hypotheses were just super creative. And it's like, okay, that takes some level of creativity for you to be able to test what is going on in a baby's brain using simple things.
Yeah, it's a perfect example. It's not obvious how to come up with those kind of psychological tests with someone who can't talk to you, right?
Yeah. So what are some soft skills that data scientists are missing that are really going to help them take their careers to the next level?
Well, the soft skills everyone kind of needs are emotional intelligence and just being able to, put yourself in the mind of the listener or the user. Definitely, I see a lot of problem with junior data scientists who meet with business people and they use a lot of jargon. They use technical terms that the other people won't understand. A very common example of this is actually the term feature engineering. It's a terrible term to use in a software company because we've got software engineers and software features. And then when you talk about feature engineering, people think you're talking about something else. And so this is just about putting yourself in the mind of the listener and remembering what's their vocabulary, what's their understanding, and how am I going to explain this term to them without, a lot of data scientists, it seems like they even want to impress people with the jargon, which is a very bad practice, unless it's other data scientists. If it's other data scientists, have at it. But if it's business people, you really need to put yourself in their shoes and convey to them the findings without the jargon, and the math. And that's just like a part of just emotional intelligence and, good presentation skills.
So how could a data scientist develop their business acumen and their product sense when they're first at a company?
Wow, yeah. It takes a while to get to know any company's product. Really, I don't know if there's a specific way to do it, but you have to really embrace it. I'm in the camp that says domain knowledge is essential, but it's actually not that hard. And I'm not the first person to say this. Everyone talks, you need domain knowledge, and you definitely do. But for someone who could learn all the data science, it shouldn't be that hard to learn the details of a particular business and business process. But you do have to care and be invested in it. You have to say, okay, it's important for me to learn this business stuff. If you try to blow it off, that's the only thing you can really do wrong, I think.
Yeah, I definitely agree with that sentiment. So what advice or insight can you share with people who are breaking into the field, whether they're fresh out of school or career transitioners, and they see some of these job postings and they look like they want the abilities of an entire team wrapped up into the one person, and they end up feeling kind of discouraged and dejected and they don't apply for the job? What advice or words of encouragement can you share with them?
Well, definitely apply. The thing is, you got to look at those qualifications and realize that not everyone has them. And also, I want to mention from the literature that there's a real gender bias in this, that jobs that have all the qualifications, so many qualifications, in general, I've read that men are more likely to apply even if they don't have all the qualifications, and women are less likely to apply. And this is just from some HR studies. So it's very important, especially for women, just apply, apply anyway, because they're not really expecting everyone to have all those skills. Unless it also says they want 10 years of experience, right? If it's for a senior role and they want a lot of experience, then okay, maybe they do want all those skills. But if it's a junior role, most of those skills are going to be nice to haves. And you need to figure out what are the core ones that they're really looking for. But the most important thing is to just get on the phone and apply anyway, or not get on the phone, but get online, get onto the website. Hopefully you'll get on the phone in a phone screen after you submit your resume. But in the phone screen, you can tell them, what your skills really are and what they're really looking for. But just at least get to that phone screen.
Thank you for that. So last formal question before we jump into a lightning round here, and that is, what's the one thing you want people to learn from your story?
I don't know, to learn from my story. Well, definitely I feel like the points around the importance of feature engineering and how most important things in data science are not necessarily the most hyped ones. You can make a big difference at your company just by, doing this kind of feature engineering, and worry about the modeling later. Worry more about, bringing understanding to your users than using the latest and greatest, modeling techniques, or the buzzwords. Stay away from buzzwords and focus on bringing knowledge to your users, is what I would say.
I absolutely love it. And that definitely picked up on that sense through your book, because you didn't present like these crazy, cutting, bleeding edge algorithms. You focused mostly on just simple, parsimonious algorithms, but really doubled down on the entire process from raw data through to feature engineering and all that. So yeah, I like that approach, and I like that lesson to learn from your story as well. So jumping into a lightning round here, if you could meet any historical figure, who would it be and what would you ask them?
I don't think, I'm not sure I have a good answer for that one. Maybe Isaac Newton. And what giants in particular were you standing on their shoulders? Because, he said, if I see farther than others, but I stood on the shoulders of giants. Who exactly was he referring to?
That's a good one. So what do you believe that other people think is crazy?
Well, in data science, I'll say I believe that deep learning models have very little to do or nothing to do with how the brain works. And that in some years from now, there will be a new principle that someone will figure out that'll actually show how brains work and process information. But it's not going to look anything like deep learning with gradients.
If you could have a billboard put up anywhere, what would you put on it?
Well, I guess I would put up like a Fight Churn with Data billboard next to the 101 in San Francisco, where, all the tech workers drive by onto the Bay Bridge every day.
Good one. So what do you love most about being a data scientist?
Well, it's that you're constantly doing new things. Like I mentioned before about doing science to me means doing something that no one's done before. So almost all of my problems at work are things that no one's really done before. So it's different to me than software engineering, where in software engineering, you're kind of, you're implementing a known solution, maybe in a new context, but you're not really doing new research. So usually in data science, you're really doing something new, which is what I really like about it.
Yeah, I really like that perspective as well. What do you wish you had known when you first started out on your career?
Definitely what's in my book, because I wrote the book. This is like a memo to my past self. If I could have gone back in time 5 years and said, focus on empirical feature engineering, don't worry about the predictive model, except with very advanced customers, that would be the message I would give myself.
What are you curious about right now?
Lots of things. I have a hobby. I mentioned that I am interested in how organic brains really process information, and I'm still interested in that. I follow neuroscientists, and I even do a little bit of coding of biologically realistic, like spiking neural networks to try to come up with my own ideas in that area.
That's awesome. So what's something you failed at?
Oh, God, in the world of data science or my personal life? I'll stick with data science. I have failed in getting my organization to always adopt best practices. And it's something I'm still working on, where there are some, data use practices that I see people in my organization doing, and I'm just like, no, they shouldn't be doing that. But I'm still kind of trying to redirect them, and so I've definitely been a failure in always getting people to adopt best practices.
What is a academic topic, or maybe just area of research outside of data science, that you think every data scientist should spend some time studying or researching about?
That's a good question. Outside of data science, a little bit. I would definitely say design patterns in object-oriented programming, very useful to have a handle on, even if you're not a software engineer.
That's a good one. So what's the number one book, fiction, nonfiction, or even one of each, besides Fight Data with Churn, that you would recommend our audience read, and what was your most impactful takeaway from it?
Let's see. That's a hard one. I didn't prepare all these before the interview, but I'm currently reading the 48 Laws of Power. I don't know if you've heard of that one.
Robert Greene?
Yeah. It's a historical book about looking at, and one lesson to that, which should be close to many data scientists, is the first law of power, which is that you need to make your boss look smart, not yourself. It's a very good lesson for any smart person embarking on their career to remember that you're not going to get a lot of points for making yourself look smarter than everyone else. You're actually going to get more points for making the other people look smart. Particularly, make your boss look smart is like the number one career advice.
I agree with that so vigorously. Yes, you should be focusing on making your boss look good, making all your teammates look good, right? Making everybody around you look good. So yeah, I'm a big fan of his protege, Ryan Holiday. I'm not sure if you're familiar with Ryan Holiday. He written The Obstacle is the Way, Ego is the Enemy, Stillness is the Key. Yeah, so that's...
All right, that can be my next read.
Yeah. He's a bit of a modern day Stoic philosopher of sorts. But yeah, it's interesting books. I highly recommend those. Protege of Robert Greene. So if we could somehow get a magic telephone that allowed you to contact 18-year-old Carl, what would you tell him?
That's funny. I might tell him to study statistics and not engineering. Because I went through this long process where first I studied electrical engineering, then I did a master's in computer science, then I did like a PhD in this neuro stuff, and then went on to Wall Street. And especially when you get into advanced machine learning, you discover that it's all about statistics, right? And the same thing with that, a lot of the Wall Street, was all about statistics. So I've had many times to wish that I had just studied statistics as an undergraduate instead of getting interested in it through all these roundabout other topics. Yeah. Although I wouldn't have done all the other interesting things I've done. So in a way, I don't know, maybe 18-year-old me should just hang up the phone and make your own mistakes.
I like that. Yeah, when I was in grad school, it wasn't called machine learning, it was called statistical learning. So it's
Yeah, statistical learning theory.
So what song do you currently have on repeat?
Currently on repeat, the Zen song by Ex-Ambassadors with K-Flay.
I definitely check that one out. So where can people find your book?
Well, it's currently only an ebook. So you can get the book in PDF or Kindle or EPUB format from my publisher, Manning Publications. The hard copy printing has actually been slowed down by COVID because Amazon and the book distributors like Barnes & Noble stopped taking delivery for a while this spring. They're actually delivering, books again, and more importantly, they're accepting books from publishers again, but my publisher's production was slowed down. So it's still supposed to come out later this summer. But right now, it's only as an ebook from my publisher's website, manning.com.
Awesome, man. I'll definitely link that to the show notes. And I'll also link a discount code that Manning has given me to share with the listeners so that they can save 30% off your book. So I'll be posting that in the show notes as well. So how could people connect with you and where can they find you online?
Okay, well, definitely social media. I'm on Twitter at Carl24K and on LinkedIn. I don't know, you just search for my name on LinkedIn. And if you want to connect with me on LinkedIn, tell me that you're interested in my book. On LinkedIn, I don't connect with random people because they might be recruiters or just trying to use my connection for recruiting purposes. But if you message me and say that you're interested in Churn, I'll always connect with you. And of course, on Twitter, connect with everyone. I've also got a blog website, Fight Churn with Data. You can actually connect with me there, but you can find more of my writings and information. And of course, there's code on GitHub. So the book has a repo on GitHub. So that's where you get all the code. And I guess that's not really a way to connect. Do people actually read messages on GitHub? I don't know. But
Yeah, your blog is awesome as well. I spent some time just kind of thumbing through all the writings that you've done on there, and it's really, really helpful. I've recommended that already to 7 people this week.
Thanks.
So, Dr. Gold, thank you again so much for taking time out of your schedule to be here on the show. I really appreciate you doing a deep dive into your book. I really appreciated you sharing knowledge and wisdom with us as well. Thank you.
Yeah, thanks for having me. Really enjoyed it.